Okay, so in this video we are going to solve two interesting questions under Newton's laws of motion. So the first question is saying two objects with mass of 3.00 kgs and 5.00 kgs are connected by a light string that passes over a frictionless pulley as in the figure below. Determine part A, the tension in the string, part B, the acceleration of each object. Okay, so this question is under pulley system. Now, when we're talking of acceleration under pulley system, the acceleration is going to be the same for both the 3 kg block and the 5 kg block, because both blocks, they are connected with what? The same string. Okay, so now first we're going to solve this question using two methods. The first method, what we need to understand is that this 5 kg is greater than 3 kgs. So we're going to assume to say the system is going to move in this direction. Okay, so now we know to say 5 kg is going to have the weight force, which we can just say W1, which is weight 1. Then this one we can say it is also what? Weight 2. So we can denote this one as mass 1, then this one as mass 2. Okay, then this is the tension. Even here we have the tension, but those tensions, they are the same. Okay, so now we need to understand to say if we calculate the weight of M1 and M2, we're going to discover that the weight of block 1 is going to be greater than the weight of what? Block 2. Therefore, the system is going to move in this direction. Okay, so if the system is going to move in that direction, then we can assume to say the sum of all the forces is going to be equal to the force that makes the whole system to come down. It is the W1, but this W1 has to overcome W2. So we're going to say that W1 minus W2. So we know that W is just basically the weight force. So we know that the weight force is given by the formula mg. So in here we are going to be specifying which m are we talking about. Okay, so we're going to say that the summation of all the forces is going to be equal to this one. We are going to say m1 times g minus this one is going to be m2 times g. Now, according to Newton's second law, we know that this part here, we are supposed to, if there is acceleration, always the summation is the same as the resultant or the net force. We're supposed to replace with ma. Okay, but in this case we have got two masses, so we are supposed to add those masses. So we're going to say that we're going to replace this one with what? M1 plus M2. Then I'm going to put them in brackets times what? Acceleration. We're supposed to add those masses. Now, why am I putting acceleration outside? Because we are saying that both blocks, they are going to be moving with the what? The same acceleration. Okay, then I'm going to say that this is going to be equal to m1g minus m2g. Okay, so I can divide both sides by m1 plus m2, even here by m1 plus m2. So I can see that these two guys, they're going to cancel out. We're going to have acceleration is equal to m1g minus m2g, everything divided by what? M1 plus m2. Okay, now from here we can plug in the values. So now we're going to have acceleration is going to be equal to, we have the m1, which is 5 times 9.8, then I put them in brackets. I have minus m2 is 3 times 9.8, I put them in brackets, everything divided by 5 plus 3. So our acceleration is going to be equal to, we just say 5 times 9.8, then minus, I put them in brackets, 3 times 9.8. I'm getting 19.6 on top, everything divided by 3 plus 5 is 8. So I'm getting the acceleration as 2.45 meters per second squared. Okay, so now I've started solving part B, then we are going to go to part A. Now, after finding the acceleration, we are saying that the acceleration for both blocks is going to be the same. Okay, the acceleration is going to be the same. So let's just put this acceleration here. We are saying that acceleration is going to be equal to 2.45 meters per second squared. Now let's talk of tension. Now when you're trying to find tension, you can use either block 1 or block 2, but you're going to find the same answers. So now let's start with solving tension with what? Block 2. So what I'm going to do, let me just get rid of this. We are saying that this is M1, this is M2. Okay, now if I'm trying to use M1, what we need to understand that we have the weight force, which is directed downward. Okay, then the tension force is up. Now this system, we are going to assume that this is the ground. Now the system is coming down here. So if the system is coming down here, block 1 is decelerating. Therefore the acceleration for block 1, we are going to denote it as what? Negative. Okay, so we are going to say that the summation of all the forces in y direction, we are going to have what forces do we have? We have got the tension force, which is pointing up, then the weight force is pointing down, so I'm going to assign it with what? Negative. So according to Newton's laws of motion, second laws is saying that we are supposed to replace this guy with what? Mass times acceleration. But this acceleration I'm supposed to replace with what? A negative sign. Okay, so I'm going to say M1A is going to be equal to T minus this weight is just M1G. So I'm going to shift this part to the other side. So I'm going to have negative M1A plus M1G is going to be equal to the tension force. This is the same as the tension force is equal to M1G minus M1A. So from here, if I want, I can factor out M. I can say that T is going to be equal to M1 open brackets G minus A. Then I'm going to have T is going to be equal to what is M1. So M1 is 5. So I'm going to put 5 open brackets. G is 9.8 minus acceleration is 2.45. Okay. So from here we can now find our tension. So we're going to start with the ones which are in brackets. So we're going to say 9.8 minus 2.45. I'm getting 7.35 inside there now times 5. Okay, I'm getting 36.7 newtons. So this is the tension force. Now if I'm trying to use M2, I'm going to get the same answer. So let's see if we can get the same answer. Okay, so now what we're going to have there is we are going to, let me just like this, 36.75 newtons. Now let me get rid of this. Okay, let me get rid of this. So now if I'm trying to use T1 or sorry M2, then I'm going to get the same answer, but it's going to be the summation of all the forces in y direction. Again, what forces do we have? We have got the weight force, which is opposing, also the tension force, which is going up. But we need to understand that this guy is moving in positive y, therefore the acceleration is going to be positive in this case. Okay, so we're going to have the tension force again minus the weight force. Since the weight force is pointing downward, then this guy is going to be M2 times G is going to be equal to T minus T is going to be M2 times G. Now I'm going to shift this guy to the other side, so I'm going to have M2G plus, oh, I have M here, I'm supposed to put M2A, this part here, because we're talking about the acceleration. So we have M2A, so I'm going to shift this guy to the other side. It's going to be M2A plus M2G is equal to the tension force. If I want, I can plug in the values direct, or I can just factor out M2. So I can say that M2 open brackets A plus G is going to be equal to T. So what is our I can just say this, what is our M2? Our M2 is 3 open brackets, our acceleration is 2.45 plus 9.8. okay, so what would be our tension force? So in this case we are going to discover that 2.45 plus 9.8, we are getting 12.35. now this times 3. Okay, I'm also getting 36.75 newtons. So as you can see, guys, both methods are correct. Even if you use M2 or M1, you're going to get the same answer. But now let's use another method because I mentioned earlier to say we have got two methods. Okay, so this is method 1. Now let's try to use method 2. Let's see. Now method 2, what we are going to do is we are going first to we're going to start getting the forces one by one. But this principle we are going to apply again to say this one is going to have weight 1, then this one is going to be what? Weight 2. Now I want you to understand that this one I'm going to say that is tension 1, this is tension 2. But the tension, this T1 and T2, they are the same. So if this object is coming here down, the acceleration is negative. But when it's going up there, the acceleration is going to be what? A positive. So we're going to start going with what? M1. So this, let's denote this one as M1 and this one as M2. Okay. So what we are going to do, we are going just to get only M1 and put it here. So I'm going to put M1 here and say that here we have the tension force, which is T. Down here we have what? The weight force, which is the same as M1 times G. Then the acceleration is coming down here, which is going to be negative. Okay. Now from there, we're going to say that the summation of all the forces in y direction, we're going to have what? What forces do we have? We have got T, which is pointing up, minus the M1G, which is pointing down. So I'm going to just put here, which is the weight force, right? Now according to Newton's second law, where there is the summation of the forces, we are going to put mass times acceleration. But the acceleration in this case is going to be negative because it is decelerating. So I'm going to put negative M1A is equal to T minus M1G. My goal is to make T a subject of formula. So I'm going to shift this part M1G to the other side. So I'm going to have negative M1 plus M2G is equal to T. So if I want, I can rearrange this and I can say that the tension force, this is T1, okay, which is the same thing. I will just like T1 is going to be equal to M1A plus, although this one is supposed to be negative, let me start lighting M2G minus M1A. Okay, so we can call this one as equation 1. Now we are done with that one, so we can get rid of this. Now let's go to M2. So if we can get M2, we have this. There's also the tension force, which is pointing up. Now there's also what? We have also weight 2, which is the same as M2G. Now in this case, we're going to discover to say the object is going up, therefore the acceleration is going to be positive. So I'm going to say that the summation of all the forces in y direction, what forces do we have? We've got the tension force pointing up minus the W2, which is just basically M2G. So now according to Newton's second law, we are supposed to replace this guy with the MA. But in this case, it's not going to be negative because it's pointing up, so it's going to be positive. So I'm going to say that the mass 2 times acceleration is going to be equal to T minus M2G. So I'm trying to make T a subject of formula. I'm going to shift this M2 to the other side, M2G. So it's going to be M2A plus M2G is going to be equal to the tension force. Let's call this one as equation 2. Now, our goal is to find the acceleration, okay? Because we can't find the tension without acceleration. Our goal first is to find the acceleration. Therefore, we know that this tension, which we're talking about here, and this tension, they are the same. So we can set them equal to each other. So we're going to say that T1 is going to be equal to T2, meaning that this part here is going to be equal to the whole of this part. Okay, so what I'm going to do now is let me just get rid of this. I create space. So I'm saying that we are going to say that T1 is going to be equal to T2. So what is T1? T1 is M2G minus M1A, okay, which is going to be equal to T2 is M2A plus M2G. Okay, so now I can get rid of, but I need these formulas. Let me just do this because they're going to help us to find the tension force again. This is equation 1. Let me just put it here and then I get rid of this. Okay, now our goal is to find the acceleration. So what we are going to do here is we are going to isolate the acceleration. So I'm going to shift this part here so that it should go to the other side. Although this one was supposed to be 1, not 2, m1. Okay, this one is m1 times m1 times g. So I'm going to shift this one to the other side, and I shift also this one to the other side. So it's going to be m1 g minus, this side is positive, so it's going to be minus m2g is going to be equal to, then there I'm having m2a, that's one in negative, going there is going to be positive m1a. Okay, now from here I can see that I can factor out, even here I can factor out g, which is the same, g open brackets m1 minus m2 is going to be equal to, even here I can factor out acceleration, which is going to be m2 plus m1. Okay, so now we have this. Okay, we have this, so we are trying to find the acceleration. So I'm going to divide both sides by what? m2 plus m1, even here by m2 plus m1. So we're going to discover that this and this will go. So we're going to have acceleration is going to be equal to g open brackets m1 minus m2 close the brackets. We have m1 plus which is the same even if I start with m2 plus m1. So now we can plug in the values. Okay, so that is our formula using the second method. So we can now plug in the values. Let's see if we're going to get, remember using the first formula we found that it was 2.45. So let's see if we're going to get the same one. So we're going to have 9.8 open brackets, m1 is 5 minus 3, which is m2. Then here we have 5 plus or 3 plus 5. So acceleration is going to be equal to, so if I get 5 minus 3, then the answer I get times 9.8, then I divide this one by 3 plus 5 is 8. So I'm getting the same answer, which is 2.45 meters per second squared. So this is the acceleration. Now, when it comes for tension, remember we have the formulas already. We discovered that this was our first equation. So you just plug in the values and you find what the tension for. So if we plug in the value there, you're going to discover that I can even this one for m1, this one was supposed to be 1 and not 2, but we have 2 there. So this one was that is T1, which is m1 g minus m1a. Then we are going to have T1 is going to be equal to, you can factor out m1 if you want, g minus a, which is the same thing. So T is going to be equal to, what is m1? m1 is 5 open brackets 9.8 minus 2.45. So if you get your calculator, you're going to discover that the answer which you're going to get is 9.8 minus 2.45, the answer times 5. I'm getting the same one now, 36.75 newtons. So even if you use this one, you are going to get again the same answer. Okay.
Thank you for making it to the end of this video. So as Transcended Institute, we are going to be providing access to the videos in physics and other courses at only a 60 kwacha until you write your exams. Okay, so we do have our own Moodle platform that allows you to access the videos at your own free time and of course at any time. Okay, so that's the beauty about our Moodle platform. So all the topics have been covered and have been recorded, so the videos are available on Moodle. All you just require is, upon making your payments, you'll be able to have your own account where you're able to log in and access the videos, and of course categorized according to the topics. So all the tutorials so far, from vectors until Newton's laws of motion, all the solutions are also provided in the video form, that is for physics. So this applies to the other courses, chemistry, math and biology as well. The topics have been covered and the videos are available on Moodle. So to register, get in touch with us by basically using the link in the description, call WhatsApp the number that is shown there. You'll be provided with more information even as you get prepared for exams. We do know as you prepare for exams, basically looking at the past paper questions and the tutorial sheet questions is the best way to prepare for exams in university. So apart from the videos, you are also going to be having interactive classes where you get to look at the past papers and you will, as learners, are allowed to ask questions. There's also a WhatsApp group for registered students where you get to communicate with the tutors. So you don't want to miss out on this, and of course do well to share the information with your friends so that they can also benefit as they prepare for the exams. Otherwise, we wish you nothing but the best as you get to prepare for exams this first semester. Thank you very much.